didn't expect such a big group, but I've been coming to this, I don't know, for a few years, I think. And this is, I think this is my third presentation. And typically what I've done in the past is I've made a ton of slides and content and ended up having to skip through it because I just had so much material that I couldn't actually cover it. So I'm going for the opposite approach today, and I think I've got 8 slides, I think, but I have a lot of hands-on stuff and demos to show you it. And I'm nowhere near as far along as Alan as far as teaching things to kids, but I have an interest in it. I think it's, I have a couple kids myself. My wife is a teacher. She did STEM teaching for kids, and so I've been really interested in trying to help out, and she's pulled me into class a few times, got me to help out with things, and so I'm interested in developing something to make it easier to do cool things for kids, and who doesn't like robots, right? And so, but robots are really hard. I know probably a good percent of the people in here have taken a stab at making a robot from scratch, and they're sitting in the corner somewhere, like, I'll fix that one day, kind of thing. So one of the things I wanted to do was to, do something where kids can interact with the robot and try and get all the frustrating parts out of it, And to my, I haven't refined, I haven't made any mistakes because I haven't tried, tried yet really, but I've kind of been attacking the technical aspects of it and trying to flesh out my ideas and stuff. So let me see if I can talk about it.
Yeah, if I push that forward. Yes.
Okay, so my goals were to have an easy way to show beginners how to work on pretty much what I just said. Hide the hard stuff, hide the intimidating things. I think we're all technical, and it's very easy for us to forget the things that are hard for beginners. It's easy to us, and I know Brian, you had mentioned something in the mailing list about easy projects for kids, and this is totally aside to my presentation, but I thought I'd bring this in. This is something I did with a bunch of kids yesterday. We talked about something simple, is that I had a group of second graders in my house, and I had to come up with a craft for them to do, and I was struggling. I was in a panic, and so I was talking it over with my kids, and they said, well, origami. I was like, I'm not an expert in origami, but let me do some of the electronics. Why don't I take some LEDs? So what I ended up doing was combining origami with some LEDs and some batteries, and so I had, I think, 8 kids for about $3 in cost for total. We put some LEDs inside some origami balls, and they were all blown away. So they all thought it was really super cool, and all of us are like, what? That's so lame. But they were all like just mesmerized by this, and they're still going. This is this little, and it doesn't do it justice if you turn the lights off. It's really cool.
So it's like a Proing?
Yeah, it's just essentially I taped some batteries together, gave the parents a, my insurance does not cover if these things explode and kind of swatting them, and then send them on the way. But so anyways, that sometimes you overlook the simple things that they really like. That we get a little more jaded as we've seen it all and everything. So that was one of my goals. Anyways, was to make something that was easy to get to the good stuff. And use things that are familiar to kids now. And one of the big things out there is, I don't know if any of you have been to code.org or have seen Scratch and the visual programming thing. And I think I'm targeting a younger group. And my wife works in elementary school and has done a lot of stuff. And we've actually, she's actually tried to teach programming to first graders. It's not, it's not pretty.
Have you ever seen We Do?
I think she has. I think.
We Do is put out by Lego, and it's there before you get to Lego Mindstorms, It plugs into the USB port, and you can just plug motors or sensors into it. And it's only sold through the educational division, but anybody can buy it, you just have to buy it through the educational division.
Oh, right. And so, yeah, and she said the same things where you were saying with the younger kids where not everybody's ready at the same time. And so you have the kids who everything went right and they're ready to move on, but they're sitting there while you're trying to help people who just hit the wrong thing at the wrong time.
Can't
and all
plug
of
the
a sudden-
USB port in.
Right, or that sort of thing. There's issues, so it's it's challenging. So, and then one of my other things was I wanted to have this I always strive to be multi-platform. So I've been aware of for a while on code.org they use this. Sorry, I skipped. I have my slides transposed from where I thought. So one of the first things for the hardware. Some of you in this group have seen me demonstrate these before. Is these little company called Pololu sells these little robot kits, and you can get them. They range from $100, and if you're vigilant and watch online, you can find them for much cheaper than that. Not for me, but from other places. But they're
not as nice as you are.
But they're really neat little robots, in that they're low cost being $100, and you could probably find some robots for under $100, but there's not too many of them, and they're a little more programmable robots. I guess you can find the mass market, those little Segway two-wheeler things that were popular last year, but finding something that's engineering friendly and open is a challenge. So I can throw this up on the projector to benefit. Is DocCam, is that what it is?
Yep.
And so you can see it's got a 328. I think it's right there. Right down there, and it's actually got these 5 little things right here are line sensors or IR proximity detectors, and so and of course it's got a little swivel, and on the front of it it's got 9-volt motors that actually does a step up, and then it's got an LCD. It's got a couple of LEDs down here, and it runs off of 4 AAA batteries. So let me see if I can turn this one on and hold on to it because I'm not sure what program it is. I think, yeah. And it's got several buttons back here, so you can use those as input in your program. So let's see if the LEDs. These are power LEDs. And then it's got somewhere on here, they're hard to see, I think it's right there, red and green LEDs. And it's also got this area right in here, I believe, is an expansion area, so they have these little daughter boards that you can put on top of it, and this is way beyond introductory stuff, but people have ARM-based boards that you can put on this daughter board on top of it and make the 328 just act like a slave device and sort of control the motors while you have a more powerful chip up top doing commands. So, but that's beyond that. That wasn't what I was trying to do. I just like the idea that this is exactly how it comes out of the box. I didn't have to solder anything. So that was one of the things in the criteria for me. And there's a bunch of other robots in this range. There's I think Parallax has a Scribbler. It's another really neat looking robot that can do line following and actually has a graphical programming environment as well. But I might be wrong. I'm not sure what platforms it runs on. I don't know if it's Windows or so anyways. It's expandable, so that was one of the other things too, is if we you know, like you had the 102, if there's some, if you want to do more cool things with it, there's always that option. It's pretty easy to add on to. And then, for the software side of it, I decided to use this tool called Blockly. And let me see if I can bring it up here. I'll bring up my site. Let's see if I can scoot this out here. All right, is that easy to read or?
Yep.
Okay. Let me, it's easy to read for everyone but me. Let's see, start. All right. So essentially what you have is this little environment that's, if anyone's ever used Scratch, it's a very similar environment to that, where you have these different blocks that you can use to do different things, and you can drag them in.
Is this cross-platform?
This is cross-platform. It runs on a. This is running in a browser, so this is, it's implemented in JavaScript, and so it works on a, Linux, Mac, or Windows. And it's just that the Arduino side, if you want to do something with this, which I'll get to in a minute, you're going to need a platform-specific hardware. So let me load an example. All right, so this is the basic blinking LED example, and there is some little glitch here that thing which shows up, but you have these blocks, and it's pretty straightforward, right? You have set LED. You can pick a color. And then you can decide if you want it to be off or on. So the idea, this is, and under the hood, all this is the digital write to an Arduino pin. So if I go on this tab right here, is that getting chopped off, or is that? Oh,
Yeah.
let's see if I can. Is that?
Yeah.
Yep.
All right. There we go. All right. So you can see that line right there is that if I went back here and turn this to off, and went back and clicked on that, it just changed it. And so that's what Blockly, the framework for doing this was this software called Blockly. It's from a couple guys that work at Google. Who wrote this, and it's used in the MIT App Inventor. If anyone's familiar with that, it's a graphical block-based system for writing Android applications, and it's also used on code.org for a lot of their JavaScript lessons. And so it's a pretty neat system. And there was a gentleman whose name I'm drawing a blank on, who took that and adapted it for developing Arduino code. So they, that Blockly has a mechanism to plug in your own languages. So the way it's set up, you can select a language. So there was a guy who went and adapted it to Arduino code. It was a little bit of a challenge because most of the existing Blockly infrastructure is geared towards JavaScript, Python, dynamic languages, kind of loose languages where you can get away with a lot more than C++. So I've had a few issues or things, and it's not too hard to go into mine and break stuff. I'm trying to close all those gaps that I run into, but And then, of course, this is up here, and, you know, I've debated, this is probably not something that you want a beginner to see at all. So, what you could do in this is you can cut and paste this and save it off. But that's just the underlying implementation of all those blocks. And so I also had this idea, this is something that I added on top of it, that you could select advanced blocks, and so then there's more options here. Advanced, you can set individual motor if you want to set a left or a right. Drop a number into that. So, let me go back to my next option. So the drawback of this, so this is really cool and all, but you can't, you know, a kid, you know, somebody, a first grader, you're not going to go, all right, we'll go into this tab, you know, do the Control C, you know, launch your Arduino, make sure your port's set up right. Now, you know, you've already lost it. So the idea is that I wanted to write you know, I'm a traditional desktop application builder, so my idea was like, well, what if I can get a desktop application that could host this application in an embedded browser and do all the nasty stuff that the browser can't do that we don't want people to have to be managed. And so I said, well, you know, I would take a stab at that. And I wanted it to be able to just hit the button and go. So that's, yeah, my slides are all transposed. So anyways, let me show you my desktop application. Have it running with actually kind of a large program here, which I don't know if it'll be able to, not be able to fit. As you can see, this one is something I was playing around with, and this is a line follower program. And so this right here is just a .NET C# application that is running an embedded version of Firefox inside the application. And so it talks. I have the JavaScript and the C# are interacting with each other perfect times. You know, and there's really all the complexity of the desktop application is not really reflected in this UI. Most of it is the difficulties in talking to the Arduino and talking to JavaScript through embedded Firefox in the DLL and all of its idiosyncrasies. And the Arduino idiosyncrasies are probably a little worse. But you know, the idea is you have some options here where you can. And this is something, these are hidden because, you know, we don't want, this will be teachers or administrators, you know, setting these things up, and selecting a core like that. All right, so you have your program, and you can take, you know, I have a programmer as well. Should have been setting up this as. So I have a little bit more than $3 I think for programmer. But so the idea is you create your blocks and you hit that button with the robot plugged in, and it does all the stuff for you. And in addition, if you really just wanted to say, well, what would it look like in your Arduino, I can hit that button and cross my fingers that I haven't run into a bug. It's popping up on this screen. There's, I should not match my there. There you see the complete, that's the whole program. So this is nice in case if you do run into problems, it's helpful. I added it first as a debugging aid for me. When something didn't go right, I can try and figure out what the problem was. And so this was my line follower. I think I've shown, when last time I had this thing in here, I showed a line follower. Or let's, and if we just push that button, and I'll hold this up. You'll see the lights blink on this thing. And the Arduino splash screen, which I can't figure out how to get rid of that thing, but hopefully we'll see a blinking. Yep, now it's doing something. And we get this like really rewarding box. I haven't worked on that. I'm gonna make something nice, a smiley face or something. So now that's running on here. And one thing I might try and figure out how to do is maybe build in that hit any key thing, because when you just have a line follower that starts right on boot, it's not good. It's trying to run off your desk. So maybe I should make that a built-in block. I've added all of these that are specific to the Polo robot are blocks that I've added in a couple language features. And for this one, this is actually not on the version that's on the website yet. I have this scary looking one called Interpolate, which all of us probably get, but I have to figure out a better way to present that to people if they want. The idea is just to map, when they're doing a line reading, it's trying to map an input to an output. I have another version that actually has the map in block form, and that was a lot scarier than that. So, I'm going to put it right under there. I have this little maze here made with electrical tape. So, and it's better. This is also not something you should do on a desk, because I do it wrong. So I'll put it right up here. And let's see, it's doing a little calibration of the sensors, and that's what happens when I turn the speed up too high. It's overcompensating. So it works. Yeah. So that would be a good example of where we're like, well, how can we make this work better? And this is one of my ideas for a lesson plan. Is maybe we could take that speed right there. What did I do? That 160?
Yeah.
That's way too high. So I've been trying to get it to work at that high speed, but I haven't been able to. So let me try it at 100.
While you're reprogramming that, I know different people learn different ways. To me, this looks visually almost as complex as the text version, but maybe it's because what I'm used to, right? Do people relate to this Graphically representation more easily?
That's a good question. In my experience, kids seem to like
To
this.
get it, yeah.
Yeah.
This is,
colors.
this is very, very similar to Scratch. And I've been in environments like in the Durham libraries and some elementary school environments where kids, say in the 10 up range, you just have to show them just the basics and then stand back and they just go crazy.
It's almost disgusting.
Well, I've
They
seen,
don't know it's programming
They're the
either. It's just playing, right?
yeah, I've seen kids 6 have no problem at all with Scratch because they start out with some simple things like, oh, I want to make this picture move across the screen, and they
Well, I wouldn't deny that if you're someone that knows a lot about programming, I look at this, I'm like, what is this?
Right.
I'd much rather type than drag
pretty
these, find these blocks and drag them and fill in.
Well, it's like, you know, I see stuff like digital writing, you were saying about the input pull-ups. I still can't bring myself to use that, because to me, I just do everything in direct port register access, which makes more sense to me. And also, I know that it's not using 40 lines of code behind the scenes that I don't want it to be running.
And that's the thing where I was talking about how the things that we overlook, where, because I'm exactly with you, where there's a very close correlation to the amount of code that gets generated in these blocks, but it's sort of like presenting it just a different way. But then when you get into things, well, you couldn't do template metaprogramming with this or something. But
Oh, yeah, I mean, you need to start somewhere. Well,
Yeah.
you already know.
I mean, I coach some FLL, some First Lego League teams, which if you've not done is tremendous. But anyway, the interesting part is the kids that have done text programming before are incredibly frustrated by Lego's graphical drag and drop, because to do things that are really simple in like a line or two of text involves really convoluted. But the kids that have never done it before, you can get a kid programming a robot in 10 minutes. You show them that and they get it because it's just so easy.
It looks like it shouldn't be that hard to translate between these blocks in text.
Right, I mean, that's
exactly what he's doing. I mean, that's what the tool is.
But if the skills.
They're just, well,
Yeah, but he's
kids
saying
who are
if you
frustrated
preferred
with
one
the
or the
blocks.
other.
So we try to move from this to the text.
Well, the fact that they are so similar, just in my naive opinion, would seem like it would be a benefit, because you could look at the code, you can switch tabs and go, oh, I see what that is,
Right, it's like watching a movie with subtitles.
Right.
Yeah, so you can.
Yeah.
You're
So,
going back and forth
And-
to see the relationship.
and in this one, I hide some of the extra, I hide the XML thing, because, this is,
I'm having problems even figuring out where the entry point is.
oh, that's,
Yeah, but there are three
gravity.
tabs.
It's gravity.
Oh,
that's gravity.
Is it like left and then left to right?
no, this is an artifact of some of the codes that I inherited, that it's actually arbitrary. The ones that are connected will be sequential, but and internally it figures out, well, these declarations need to get generated up top, so we can worry about that. But one of the things I added was this special setup block, which directly maps to the setup function in the Arduino. So I've been trying to think of ways to make that work better, because I agree, I don't like these floating things, but these are actually procedures, so they're not, but what I would like to have is like maybe something like,
a function that you call from somewhere else.
right, yeah, I'd like to have it more obvious to people.
So where do you actually, so you have setup, so where's the loop?
Everything else,
Everything.
else.
Starting where?
Well, it
You
might,
can't see the loops.
yeah, actually, I mean, it might,
You should become a Sikh.
it's gonna start right here. If you look at,
The loops start with the word do.
that is function. There's the setup, and the code actually inserts initializations for where it needs to, and then the check battery call is right here. So, and then here's the main loop. So watch, I'll put a.
Yeah, I think the way it works in Scratch is when you first create a variable, you give it the type, and so it doesn't actually have like a declare type when you first made it behind the scenes. It knows that type and they're different shapes.
And one thing that makes it a little harder, given that it's Arduino and not JavaScript and Python that are much more loose with very, the Blockly don't have to worry about that so much because they just, their variables can be anywhere. So one of the biggest bugs that I have also in mind is that return values for functions are totally broken because it doesn't handle it well. But if we look at this example, if I go back to the code, we'll find where this is going to be in the loop, but whether it's before this group or the other one, I don't know what determines that. Yeah, it's at the bottom. So it may be because it was added second, or it might be because it was lower.
Slightly lower on the screen.
I'm not sure. Yeah, that's a good experiment. But I don't like that. That's confusing. That's something. That's on my list of things that I'd like to fix.
Those are independent computational patterns. So they don't.
Yeah, I guess you could argue that. Yeah. But it's also not obvious from this that those things run in the loop. Might be something that's gonna hit this thing again, and you let it exit out the back.
It might be worth it to have one that just said loop, that was the main loop.
Yeah,
Whatever you put in there is gonna.
and that's one of mine, and maybe not let them put anything else out, or or only certain, you couldn't have something like this hanging off there. You gotta stick it either in a loop or in a setup or in a function or something, just a. But I mean, these guys who wrote this did amazing. I don't mean to.
The Lego Mindstorm has the train track that joins things together, and there's
Right.
it's kind of a starting function.
So it's updated to a slower speed, so it should work better. Yeah, so it's a little. It's still pretty fast. I was trying to get it to go even fast. I wanted it to go really. I thought an interesting exercise. If you had a bunch of people doing this, would be a contest to see who could get it to go the fastest. Without going off
The
course.
right angle turn.
Yeah, if you curve the line so that
It's doing right angle turns.
you can probably go faster with curves, right?
Probably.
As they go off when it hits.
I have another track at home that my son and I made that's with Sharpies, and it's really interesting. This is electrical tape, but the one of the Sharpies it's all over the place, but it's curvy, but there's a couple curves that get a little too close to each other, so it'll jump sometimes. Let's see, I think that was most of my. Let me see if I have any slides left. Yeah, I get into technical details, which I don't really know if it's that important. Anybody who's interested probably can easily figure that out, but. That's basically how it works. Some of this was really tricky, and Arduino 1.5 is the earliest version that does things on. You can actually run it from the command line. Earlier versions didn't support that, but it does still, even though it's from the command line, it still pops up in slash dialog, which drives me crazy. So maybe 1.6, maybe they got rid of that, but. And then I had some other really interesting, this is getting kind of really technical, but I had running Firefox in the browser would introduce some DLLs or something in my environment that would make GCC, when launched from the Arduino, just not happy and it would not work. And so what I had to do to fix it, and I narrowed it down to if I loaded the DLL for Gecko, which is the .NET embedded Firefox framework wrapper, if I loaded that anywhere and later tried to on the Arduino, the GCC, it would fail and it would complain. And so what I had to do was I actually launched 2 instances of my application and have them remotely talking. So one of them doesn't load the Firefox, and it says, okay, it's time to launch your Arduino, and here's all your parameters. But you never see the second one. It runs without a GUI in the background. that was a weekend of gray hair. So I think does anyone have any other questions?
So my sense is that if you arrange to stay on the middle of the road, worked out an application, some set of applications, that you could then put that into a classroom situation and
Yeah.
stay 50 miles away from the DLR faults
Oh, right.
and so on. I mean, this is pretty much an experimental system at this point that you've been developing. Is that right?
Yeah, it's sort of experimental, I mean, but I've been sort of encouraged. Here's some of my challenges. I actually recently had a little bit of conversation with the authors of Blockly and showed them what I did, and they asked if I'd be willing to update the Arduino Blockly with the latest changes from the core, and I would love to, except I'm probably not the right person to do that.
Does it run on platforms other than Windows?
In a browser.
The browser
Oh, it
version.
runs in a browser?
Yeah, we go back to that.
So,
The back end is an Arduino IDE, so.
oh,
So
okay.
this green part,
Which is also cross-platform.
So,
this,
so you can get around that DDL problem if you run it on other, or,
Yeah, but you get a whole nother range.
right, yeah.
Oh.
Actually, it's the GCC that's the problem. You scared him.
well, Windows is known, people tend to overwrite DLLs. Different companies use the
It's
exact
actually
same
in
names.
memory. It's something gets loaded into memory. If something Firefox. I don't know what it's called, but the green part, this part is all in HTML and JavaScript. So the part I was showing, if you go to my website, is just that green part. So, but that's the one where you have to cut and paste the code into your own. You just have to get the IDE yourself and paste the code in there. So the purpose of the Windows app is so first graders don't have to do that. And so Windows, it's just my forte, so I can do it a lot faster than that. So here's some of the other things I wanted to do. Different robots. It'd be really interesting to figure out, to have different platforms. I just picked this one as the first, because it's a low-hanging fruit, but I think it'd be cool to do different ones. More types of blocks. And I have really primitive documentation, as we engineers tend to have. And my next steps are to, the Windows thing that I showed you is not public yet, I'm still working on it, so I want to get that out, make some more examples, some more plans, and